Hello friends, welcome to my channel Academy for Engineer. So in my last lecture, I have discussed about various types of number systems. So today I am going to explain some numerical based on number systems. So this table I have already discussed in the previous lecture. So today we will discuss few numericals. Now in this particular example, I am going to convert a hexadecimal number into its decimal equivalent. Now, how we can convert hexadecimal number into decimal number, that I am going to explain. So there are few steps for this particular conversion. So here the number given is 19FDE. So this is the number given to us. It is in hexadecimal number. We want to convert this number into decimal number. So for that, what we do in the first step, what we do, we will take the number and we will multiply each bit of this number by its equivalent weight. So as we know that E is equivalent to 14. So 14 is, this is your E. So E is first multiplied by 16 raised to power 0. This is the weight of this bit. Similarly, this B is the weight of this D. This D is having the weight of 16 raised to power 1. This F is having weight of 16 raised to power 2. So in the same way, we are multiplying each bit by its corresponding weight. So once we multiply each bit with its weight, in the next step, we will convert all alphabets into its decimal equivalent. So here you know that this F is 15, E is 14 and D is 13. So we are replacing all alpha letters by its number equivalent. So once you solve this particular equation, you will get 65,536 plus 864 plus 3,840 plus 208 plus 14. So once you add all these values, you will get 1,06,462. So this number is in decimal number. So it means 19FDE, which is in hexadecimal, is converted into its decimal equivalent. Now moving forward. So here I am going to convert a decimal number into a binary number. So here the decimal number is 19. So we will take 19 as a decimal number, and to convert this number into binary number, we will divide the number by 2. So once we divide the number by 2, we will get 9 as a quotient and 1 as a remainder. Similarly, again this 9 is divided by 2. So in this case, you will get 4 as a quotient and 1 as a remainder. Further, this 4 is divided by 2, we will get 2 as quotient and 0 as remainder. Further, this 2 is divided by 2, you will get 1 as a quotient and 0 as remainder. Further, we will divide 1 by 2, then this is not divided, so we will get here 0 as a quotient and 1 as a remainder. So this bottom bit is called as MSB and this top bit is called as LSB. So from moving from bottom to top, you will convert this decimal number into binary. So binary number comes out to be 10011. So finally the answer is 10011 with the base 2. So in this way you can convert any decimal number into binary number. Now moving ahead. In this slide I am going to explain one problem related to hexadecimal conversion to decimal conversion. So here the number is given D5 with base H. With base H means it is in hexadecimal. I want to convert this number into decimal. So you already know that what is D? D is nothing, it is 13. And this 5 5 is written as 5. So we have equivalent conversion. This is in hexadecimal. Its equivalent in decimal is 13. This is in hexadecimal. This is also 5 in decimal. So what we do, we will convert. Once you want to convert any number in hexadecimal to decimal, we will multiply each bit of the hexadecimal number by its corresponding weight. So 5 is multiplied by 16 raised to the power 0. Why 16 raised to the power 0? Because the base is 16. And as you know, d is 13, so 13 multiplied by its specific weight is 16 raised to the power 1. So once you multiply 13 by 16, you will get to 208, and 5 multiplied by 1. So 5 multiplied by 1 will give you 5. So answer becomes 213, which is in decimal. So that's why the base is 10. Now come to the next point. There are two more problems related to hexadecimal to decimal conversion. So this is your hexadecimal number, and there is a conversion for decimal number. Similarly, this FFFF will be converted to decimal number, which is equivalent to 65,535. So I can solve one problem for you. So if you take E9, so I can write here. If I write here E9, so this is in hexadecimal. What is E? You know that E is 14. E is 14, and this 9 is same. So what I do? I will multiply by its weight. So 16 raised to power 0. So I have to multiply it by its weight. Similarly, E is 14. So I have put the value E equal to 14 and multiply its weight. Then it is 16 raised to power 1. So if you multiply 16 by 14, you will get 224 plus 16 raised to power 0. Any value having power 0 is equal to 1. So 1 multiplied by 9 is 9. So you will get 233 in hexadecimal. So I put here, what I put here, I will put base 10. So in this way you can convert that hexadecimal number into decimal number. In the same way you can proceed like this. Each f is multiplied by its bit. So once you multiply all the f value with its specific weight, you will get this value 65,535. Coming to the next point. Now in this particular problem, we want to convert a decimal number into hexadecimal. In the previous case, we have taken conversion from hexadecimal to decimal. But here we are trying to convert a number from decimal system to hexadecimal system. So here this 213 is given in decimal and we want to convert into hexadecimal. So what is the procedure for that? Any number in decimal can be converted into hexadecimal by dividing the number by 16. So here the number is given 213. So we will divide this number by 16. So once you divide this number by 16, we will get 13 as a quotient and 5 as a remainder. Again we will divide this 13 by 16. So it is not divided. So we will get 0 as a quotient and 13 as a remainder. Now this 13 you have to convert into हेक्साडेसिमल. सो 13 का जो इक्विवेलेंट होता है हेक्साडेसिमल में दैट इज डी. सो यू हैव टू मूव फ्रॉम bottom to top. So bottom is D. So we write D first, then we will write 5. It means this 213 is equivalent to D5. So in this way we can convert decimal number into hexadecimal. So there are certain problems related to hexadecimal to binary number system. So how we can convert? So here this 25 is given in hexadecimal. We want to convert into binary. So whenever we are converting any number to binary, every time we have to use the bits 0 and 1 because its base is 2. So how we can convert this hexadecimal to binary? So as you know that in hexadecimal we use a combination of 4 bits. Every time we use a combination of 4 bits which can be either 0 or 1. So how we can write this 2? So 2 can be written as in this way, 0 0 1 1. So this is equivalent to 2. And why I have taken 4 bits, combination of 4 bits, because 2 raised to the power 14 is nothing, it is equal to 16. 2 raised to the power 14 is equal to 16, and 16 is the base of hexadecimal. So that's why I have taken a pair of 4 bits. So this 4 bits is representing 2, which is equal to this value. Now similarly, this 5 can be represented in a combination of 4 bits. So how we write 5? So 5 can be written as 0 1 0 1. So if we combine all these values, this will be equal to binary conversion. So in this way, we can convert hexadecimal into binary. So this is the value that I have explained to you. Similarly, in the same way, how you can convert 3A7 to binary number. So 3A7 is in hexadecimal. Why it is in hexadecimal? Because it is written here A. So A is only existing in hexadecimal. So to convert 3A7 into binary, we will proceed in the same manner as in the previous example. So 3 can be written as, so here 3, as you know that 3 is equal to, how we can write in terms of 4 bits? So it is 0 0 1 1. This is equivalent of 3. Now how we can write A? So A is equal to 10. So this can be written as 1 0 1 0. So this is equivalent to 10. Similarly, we can write 7 as, 7 is equal to, it can be written as 0 1 1 1. So this is your 3, which I have written here. This is your A, which is equal to 10, and this is your 7. So you can convert this number into binary number. In the same way, you can convert hexadecimal into binary. So here the example is C, D, E or 8. So C is equal to, this is the equivalent of C. So D is equivalent to this. Similarly, E is equivalent to this, and D and 8 is equivalent to this value. So every time the letter is represented by a combination of 4 bits. So in this way we can convert hexadecimal number into binary number. Now this slide will show you how to convert a binary number into decimal number. So this is the binary number given to you. You want to convert into, it's not decimal, it's basically hexadecimal. So it is hexadecimal. We want to convert a binary number into hexadecimal. Okay, so binary is given to you. So to convert binary to hexadecimal, we will make a pair of 4 bits. So make a pair of 4 bits starting from the right side. So we will make a pair of 4 bit. We will make a pair of 4 bit. So this value is something, it is equal to capital D, and these 4 bits is equivalent to capital A. So it means this value comes out to be AD. So it is in hexadecimal. In the same way, this number which is in binary can be converted into hexadecimal like this. So how we will proceed? In this case, there are only 6 bits and we have to make a pair of 4 bits. So what we do? We will insert 2 zeros to the left side. So here we have inserted 2 zeros so that we can make a pair of 4 bits. So we will make a pair of 4 bits like this. We will make a pair of 4 bits like this. So this value is 5 and this value is 3. So answer is 35H. In the same way, this is the third problem related to binary to hexadecimal conversion. Here you can see there are total 6 bits. So we cannot make a pair of 4 bits. So what we do? We will again add 2 zeros to the left side of the number. So here we have added 2 zeros. Then we will make a pair of 4 bits. So make a pair of 4 bits like this. So this value come out to be, this value is B and this value is 3. So answer is 3BH. So in this way you can convert binary number to hexadecimal number. Now this slide will show you how to convert octal to decimal. If you have a octal number, you want to convert it into decimal number, then this table will help you in converting a number from octal to octal to decimal number. So here this is the decimal number, this is the octal number, and this is the binary equivalent. So as you know, in decimal we are using number from 0 to 9. So here we are only considering 7 numbers. In octal, because base is 8, so it will only uses eight digits, which are ranging from 0 to 7. So this 0 can be written as 0000. Here we are taking a combination of 3 bits. Why 3 bits? Because you know that 2 raised to power 3 is nothing, it is equal to 8. So that's why we are taking a combination of 3 bits, and 8 is the base of octal number. So 1 can be written as 001, 2 can be written as 00010, 3 can be written as 011, 4 can be written as 100, 5 can be written as 101, 6 can be written as 110, and 7 can be written as 111. If you write here 8, then we can write, how we can write this? So in this case, you cannot write you have to represent this 8 in terms of combination of 3 bits. So in this way you can represent the number in binary. So here it is the process how to convert octal to decimal. Now this is given to, the number is given to octal, you want to convert into decimal. So to convert octal to decimal, you have to multiply each bit by its octal weight. So 5 is multiplied by its specific weight, 8 raised to power 0, and 7 is multiplied by 8 raised to power 1. So 7 into 8, 56, plus 5. So answer comes out to be 61. In the same way, we can convert decimal number to octal. So this 68 is given in decimal, and I want to convert this number into octal. So what we do, in order to convert decimal to octal, we will divide the number by its base. So base is 8. So we will divide 68 by 8. So once you divide 68 by 8, so you will get 8 quotient, 4 remainder. Then again divide by 8, you will get 1 quotient, 0 remainder. Again divide by 8, so quotient becomes 0, and this comes out to be 1 as a remainder. Again moving from bottom side to top side. So once is written first, then 0, then 4. So it means 64, which is in decimal, is converted into 104, which is in octal number. So here is the table for converting octal to binary. So this is in octal. So 2 you have to represent as a combination of 3 bit. So we will represent like this. This is equivalent to 2. 7 is equivalent to 117. So decimal becomes 23. In the same way, if octal is 135, so first we convert octal into binary. So 1 can be written as 001, 3 can be written as 011, 5 can be written as 101. So this is, if we solve this value, it comes out to be 93. So how this 93 comes from this? We will multiply each weight by its binary weight. So this 1 is multiplied by 2 raised to power 0, then 2 raised to power 1, then this bit is multiplied by 2 raised to power 2, then this bit is multiplied by 2 raised to power 3, 4, 2 raised to power 5, 2 raised to power 6, and so on. So once you add all these values, you will get 93. Okay. So in this problem, we can convert binary number to octal number. In this case, the number is represented by 5 bits. But in order to convert binary number into octal, we need a pair of 3 bits. So what we do, we will insert a 0 here in the left side. Then we can easily make a pair of 3 bits. So you can see here. Here we can make a pair of 3 bit. Here we can make a pair of 3 bit. So this is equivalent to 5. This is equivalent to 2. So we will get 25 in octal. In the same way, in the second problem, we can convert this number which is in binary into its equivalent octal. So here total bits are 6. So we can make a pair of 3 bits easily. So I have make a pair of 3 bit here. I have made a pair of 3 bits here. So this is equivalent to 7. This is equivalent to 50. This is equal to 5. So total becomes 57. So in this way you can convert any binary number into octal number. So if you like this video, please subscribe my video, and in the next video I am going to explain some fractional parts, how to solve the fractional part related to binary, octal, hexadecimal and decimal number. Thank you for watching my video.